Hello, welcome to Algebra. In this session, we're going to be talking about patterns, and in particular, we have a few learning goals that we're working on today. First, we want to be able to recognize and describe patterns. You know what? You can probably already do that. We're going to work on refining that skill a little bit, but I bet you already know a lot about patterns. We will be representing patterns as sequences. We'll be predicting the next term in a sequence and representing a sequence as a table of values. Now, you guys already know a lot about patterns, but one thing we're going to do today is use some vocabulary that you may not have used quite as much. We'll talk a lot about the term sequence, the term of a sequence, and we'll discuss the differences and similarities between infinite sequences and finite sequences. But before we get too far into all of that, let's do today's warm up. So for today's warm up, there are 4 questions. And you know what? Normally for a warm up, I would ask you to work on your own. But for this warm up, I want you to work with a partner. And let's just see how many you can solve. Can you do all 4? Fantastic. Don't feel like you have to get all 4 though. See how many you can figure out. I think you can figure out a lot. Do as many as you can. Let's set a timer for 5 minutes. And in 5 minutes, we'll come back together and we'll talk about what you guys discovered. So hit pause, set a timer for 5 minutes, and let's talk after that. All right, so you've hit play, which means you've had some time to talk about these sequences. I'm actually going to ask you to pause in just a second because what I want you to do is share out with the class what you noticed and what you think the next term is for each of these sequences. So pause the video and have a class conversation. Talk about what would be the next term, what would be the next 3 terms, and what is the pattern. So you hit play again, so that means that you are ready to talk about these. I want to actually work backwards, so I'm going to start by talking about number 4. One thing I noticed is that 100 is equal to 10 squared. 81 is equal to 9 squared. 64 is equal to 8 squared. 49 is equal to 7 squared, and we could keep going. So the next 3 terms in the sequence would be, let's see, 6 squared, 5 squared, and 4 squared. That's 36, 25, and 16. Fun, huh? So let's write those down. 36, 25, 16. And what's going on here? We're having, this is a pattern that's x squared. And it's descending. We started at 10 squared, and we're going down to 9 squared, 8 squared, 7 squared, and so on. When you're describing a sequence, one thing you can do to tell people that the sequence continues is use these little dots. That's called an ellipse. 1, 2, 3 dots like that. And what that means is, hey, this pattern keeps on going. This isn't the end of the pattern. It's not the end of the sequence. That's what those dots mean. So this next one might be our easiest. We're just counting by 5s. 5, 10, 15, 20, 25, 30, 35. We could go on and on, but we only need 3 terms. Next, let's see these letters. SMTW. I bet y'all got it. Days of the week. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And you know what? This pattern does not continue going further than that, does it? Because that's the end. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, boom. That's all there is. Let's look at the top one. This one is similar to the one with the days of the week, except for it doesn't represent the days of the week. It represents something else on the calendar. Did you guys get it? January, February, March, April, May, June, July, August, September, October, November, December. It's the months of the year. So these are all different examples of sequences. And today we're going to be describing sequences mathematically.